This is a key to the worksheet on continuous growth and decay. Now, in all these problems, it does mention the word continuous. So since it mentions the word continuous, we're going to use this formula in these problems. So we're going to use the formula A equals P times E to the RT power. So where R is the rate and T is the time. And P is would be the original amount in each of these cases. And A is the amount you end up with after a certain period of time. So if you look at number one, you have Susan invested $3,000 in an account earning 9% per year compounded continuously. So there's that word continuous. How much will be in the account at the end of 4 years? And make sure you round correctly, in this case, to the nearest cent. All right, so the setup, so in terms of the setup, you're going to do this. So this $3,000 here will be P, the original amount, or in this case, the principal. And then the rate would be 9%, but you're going to write this as a decimal, so 0.09. And then the 4 here would be the time. And so your setup, you're going to say A equals $3,000 times E to the, and then the exponent, we're going to put that in parentheses because when we put this in a calculator, this will be in parentheses in the calculator. So R would be 0.09, so 0.09 times, and then the time is 4. And so we're going to approximate to the nearest cent. So let's go and use a calculator. So make sure you know how to use your calculator on these. All right, so we're going to have 3,000. So 3,000 times E. Now to get to E on my calculator, I've got to press second LN button. So right above the LN button in blue is the exponential function E. And so notice you get E raised to, and it automatically puts a parentheses there for the exponent. So you're going to say 0.09 times 4, close the parentheses, and press equal. All right, so notice, remember it says the nearest cent. So the nearest cent in terms of dollars is the nearest hundredths place. And so the hundredths place is the digit 8. So 4,299.988244 and so on. So this first 8 here that I'm pointing to is the hundredths place. So that's the nearest cent. You have to look at the digit to the right of it. Since that is 8, which is greater than 5, I've got to add 1 to the 8. And so the answer will be, to the nearest cent, will be 4299.99. All right, so that's the answer. So $4,299.99. Okay, number 2, a radioactive element decays. Now, the word decay is important here at a continuous rate of 12.7% per day. How much will remain of 200 milligrams of this element after 5 days? All right, so the word decay is going to imply that my rate is negative. So when I use our formula right here, we're going to have this. We're going to say A equals, so the 200 is the original amount, so it'll be P, 200, times E in parentheses, remember in parentheses, RT. So your rate, though, is decaying, so, the element's decaying, so the rate's going to be negative 12.7%. So negative 0.127 times, and then the time here is 5 days, so times 5. And then let's go and use a calculator. So remember, since it's decaying, your answer better be less than 200. So if it's more than 200, you did something incorrectly. So it has to be less than 200 because this element is decaying. All right, so on your calculator, you're going to do this. So you're going to say 200 times second E. So you get this exponential function times E raised to the negative 0.127 times 5 rather, and then close the parentheses and press equal. So that's what we get. Now they want us to round to the nearest tenth. Okay, so the nearest tenth. So let's remind ourselves what this looks like. So the nearest tenth, when I'm going to go ahead and write this down. So I have 105.9870 and so on. So here's the nearest tenth right here. Okay, that's a 9. Some students get confused what to do when there's a 9 there. So the nearest tenth, you have to look at the next digit. Since that is greater than 5, I have to add 1 to the 9. So when I add 1 to the 9, it becomes 10, like this. So this becomes 106.0. So that will be 106.0. So you have to have something in the tenths place, and that something has to be 0. All right, so the answer is 106.0. And then there'll be milligrams. Okay, number 3. A car is valued at $32,000 in 2016. It's continuously depreciating, so there's our word depreciating, just like decaying, at a rate of 8% per year. How much was the car worth in 2020? And then round to the nearest dollar. All right, so A equals 32,000. So 32,000 times E raised to the rate. Remember, this car is depreciating in value, so the rate's going to be negative. So negative 0.08. So 8% as a decimal is 0.08. Negative in this case because it's depreciating. Times, and then 2020. So you're going from 2016 to 2020, which implies that the time is 4 years. All right, so times 4. And let's go ahead and approximate that. And remember, you want to round to nearest dollar in this case. So the nearest dollar means the nearest whole number. All right, so when I put this in a calculator, I'm going to get 32,000, just like this, times E. And I'm going to get negative 0.08 times 4, close the parentheses, and press equal. All right, so in that case, I'm going to get this now. So I'm going to remove this part. So I'm going to get 23236.769 and so on. All right, so the nearest dollar means the nearest whole number. So you're going to round to the ones place. But you have to look at the tenths place. So since that is greater than 5, I'm going to add 1 to the 6. So this is going to become 23237. Okay, so $23,237. So that will be the answer there. So 23,237. All right, so that is the answer for number 3. So notice it's depreciating, so your answer has to be less than what you started out with. Just like in number 2, 106.0 milligrams is less than 200. All right, number 3, a building which was built at a cost of $150,000 appreciates. So appreciate versus depreciates. Depreciates decreases. That's why our rate was negative. Appreciate grows, so our rate will be positive. So a building which was built at a cost of $150,000 appreciates continuously at 3% per annum, so per year. What is the value after 6 years? And then you want to round to the nearest dollar. All right, so A equals, and then $150,000 times E raised to the, now remember, since it talks about continuously, that's why we're using E here. So anytime it indicates continuous, you're going to use the exponential. All right, and so it's positive, so 0.03 times the time, which is 6, and then we're going to approximate this, and again to the nearest dollar, just like in number 3. So using the calculator, we're going to get this. So 150,000 times E, and then our exponent is going to be 0.03 times 6, close the parentheses, and press equal. So remember, it's appreciating, so our answer has to be greater than $150,000, and it is. So notice the nearest dollar means the ones place. So now you have to look at the tenths place. Since this is greater than 5, greater than equal to 5, 6 is greater than equal to 5. you have to add 1 to the 2. So 179583. So 179583. All right, so $179,583. Okay, number 5. In 2020, the club membership had 400 members with an annual growth of approximately 4% compounded continuously. So there's that word continuous. So that's why you're going to use this formula up here. What will be the membership in 2025? So you went from 2020 to 2025. So the time here is 5 years. All right, so we're going to get A equals, the original membership was 400, so that'll be 400 here, times e to the, and it's growing, so 4% will be positive, so 0.04, times the time, which is 5, and you want to round to the nearest whole number. So when you're usually talking about people, we tend to round to the nearest whole number. All right, so let's see what we get. So we're going to get 400 times e, just like this. 400 times e raised to the 0.04 times 5, close the parentheses, and then press equal. So to the nearest whole number, again, you got to look at the tens place. So since that is 5, so 5 or greater, you got to add 1 to the 8 to the tens place. So that'll be 489. So 489. So in 5 years, the membership will increase to 489 members. All right, and so that is it. That is the key to the worksheet on continuous growth and decay.